Welcome to section 1.5, combinations of functions. We're going to be looking at addition, subtraction, multiplying, and dividing functions, and also finding compositions of functions. The first four operations of functions, sum, difference, product, and quotient. All this is really shown on this page is the notation. So, we're used to seeing things as we're taking f of x plus g of x. Well, another way to write that is to say f plus g and then of x. So really this first slide is just showing you the notation of the different operations of functions when you see them. Same thing with difference. We're typically used to seeing f of x minus g of x, but it can also be written as f minus g of x. And once again, just understanding that notation in terms of that. So it works for all four. Once again, product f of g of times g, or sorry, f of x times g of x is the same thing as f times g of x. And now when you look at division, I want you to be careful because the division, f of x divided by g of x, once again, f divided by g of x, but we have a little stipulation here on this one, and that's g of x cannot equal 0, and that's because we're dividing. So whatever that function is on bottom, there's a restriction, and we're going to have to look at that restriction and indicate what that value cannot be. So really looking at the domain and talking about the domain of that g of x. Not being equal to 0. Okay, so probably pause it, go ahead and write those down, and we're going to kind of move on to look at some of these different operations. First one, given functions f of x and g of x. So I've given you two functions. We're just really going to go through the basics of addition, subtraction, multiplication, division, just so you can see all four of them. So the first one, I want you to find f plus g of x, and then I want you to find f plus g of 3. So the first thing that we're going to do is we're going to take the two functions and we're going to add them together. So I'll write it as f plus g of x, and that's the same thing as f of x plus g of x. And so we're just going to add those two functions together. And you could probably simplify this process a little bit. I'm going to go ahead and make sure I write everything down so you can see where everything's coming from. And so I'm taking f of x plus g of x. Make sure you do it in the order that it's asking. Now with addition, not a big deal because sum is commutative. So we can combine our like terms. I want to make sure we have it in standard form. So we're going to put the x squared first, plus 4x, and then the plus 1 and minus 1 cancel out. So one of the things in this class that I'm going to be particular about is answering the question. So f plus g of x is equal to x squared plus 4x. So that whole thing is your answer, not just x squared plus 4x. And now the second part of this. The second part of this is to find f plus g of 3. Well, now we have f plus g of x, we can just plug 3 into the function. So I'll kind of do that over here. So f plus g of 3 is equal to 3 squared plus 4 times 3. And then you can evaluate that. That's 9 plus 12. So f plus g of 3 is equal to 21. And so those are the two parts that I'm looking for in terms of these operations or combinations of functions. On the second one, f minus g of x. I mean, you can kind of really just work along with me while I'm doing this because, as I said, we're just combining like terms. Once again, pay attention to the order that these are going in. This one's f minus g of x. So we have f minus g of x. So that's the same thing as f of x minus g of x. And so that's equal to 2x plus 1 minus, and since I'm subtracting an entire function, you've got to have the parentheses, so you have got to have minus that quantity. And when you're subtracting an entire function, you're really distributing that negative sign all the way through. So that's minus x squared minus 2x plus 1. And then now you can combine, once again, putting it in standard form. We have negative x squared, the 2x is canceled, and then the 1 plus 1 gives you plus 2. So f minus g of x is equal to negative x squared plus 2. And then once again the second part, f minus g of 3. and plugging in 3 into your new function. Pay attention on this because I'm going to write it as negative x squared plus 2 because that's what f minus g is. When you plug 3 in, the question that I would ask you is the 3 being squared, or is the negative 3 being squared? And if you look at it, it's negative x squared. So if you plugged in a number, is the x being squared or is the negative x being squared? And since it's not in parentheses, alright, it's just negative x squared, the x is the only thing being squared, the negative comes second. So it's negative 9 plus 2, which is equal to negative 7. So f minus g of 3 is equal to negative 7. So be careful with those quadratics and squaring, especially dealing with negatives. So there's addition, there's subtraction, and then we're going to have multiplication and division. So apparently something didn't come out right on my notes, but that's okay. I'll fix it as we go here. So the functions f of x equals x squared, and the function g of x is equal to x minus 3. So the first thing I want you to find is f times g of x, and then we'll do f times g of 3. Alright, so we will do f times g of x, that's equal to f of x times g of x. So we're just going to multiply those two together. So that's x squared times x minus 3. We distribute, and that'll give us x cubed minus 3x squared. And once again, that's it in terms of the multiplication. So f times g of x is equal to x cubed minus 3x squared. Nothing else you can do in terms of that. The second part, plugging in 3. So f times g of 3, wherever there's an x, you're going to plug in a 3. So it's 3, if I can make a 3, 3 cubed minus 3 times 3 squared. So a lot of 3's going on. 3 cubed is 27. Minus 3 times 3 squared is also 27. So that's equal to 0. So f times g of 3 is equal to 0. And so there's your multiplication. So you can probably guess what the second one is, or was supposed to be. This is going to be our division. We're looking to find f divided by g of x, and we'll do the same thing, and f divided by g of 3. So pretty much the same question I was asking, but with division now. And so with this, we know that f divided by g of x is just taking the f function and dividing by the g function. So what do we get? We have x squared divided by x minus 3. And some of you are going to try to cancel the x's because you think you can, but these are not factors. Factors are products of things. So the only way x's are going to cancel is if it was x times 3, not x minus 3, then they would cancel. But with subtraction, you can't cancel unless it's a product. So really at this point you're done with the division. F divided by g of x is equal to that. The only other thing is, what's that restriction? Well, we can't have x cannot equal 3 because 3 minus 3 is 0, and that's undefined. So you want to include that restriction when you're doing your division. And then the second part, plugging the 3 in. So f divided by g of 3. Struggling to make my 3's today. Is equal to 3 squared over 3 minus 3. Well, we just said x cannot equal 3, so we get 9 divided by 0, and that's undefined. So there is, f divided by g of 3 does not exist. And the reason is it has to do with the domain value. So this right here does not exist, and the reason is because 3 is not part of the domain, and so therefore it doesn't exist. So there's your addition, subtraction, multiplication, and division of functions. Pretty typical in terms of what you've seen in terms of, you know, adding, combining like terms, using the distributive property, things like that. But really maybe just more of the notation that we're looking at in terms of the combinations there. So that's kind of the first part I wanted to show you, addition, subtraction, multiplication, and division. And then the second part I want to get into is compositions of functions. A composition of a function f with the function g is written as, looks like fog, f of g of x, and the other way it's written is f parenthesis and then g of x. So you can write it either way. I kind of like the second notation better. It kind of gives you that, you know, you do what's inside first, and so that g of x is what's inside, so you would do that first. But you need to know both notations, and it is read, just as I said, f of g of x, because there's multiple things going on. Does f of g of x have to equal g of f of x? And I could show you a lot of different examples that work, but I could also show you a lot of different examples that don't work. And we'll kind of talk about, you know, when does it work, or when should it work, and when shouldn't it work. And really, before we get into this, let me just kind of explain what a composition of functions is. A composition of functions, I mean, this is, I think, the best way to explain it is basically you have two functions or two machines, all right, doing two different things, and you want to combine them to do one thing. Here's an example. You have a washer and a dryer. You put your clothes in the washer, it washes the clothes, you take them out of the washer, you put them in the dryer, and it dries the clothes. And so what we want to do is create one machine that does both those things. So you throw it into one machine, it washes the clothes, and then somehow it dries the clothes also, and then you take it out and it's all done. And that's what a composition of functions does. Instead of plugging it into one, taking it out, plugging it into another, and then taking it out, and kind of going through that 2 or possibly even 3-step process, if you have, you know, a composition within a composition, you really can just do one thing. You plug it in, and then it does its thing, and you take it out, and you're done. And that's really what a composition of functions does. It simplifies that process a little bit. So let's just kind of practice this with example 3. We have f of g of x and g of f of x. We want to find both of them, and you can see we have f of x and g of x just as before. And so we'll do the first part where we're doing f of g of x. And so just as I said, you kind of work from the inside out. So this first part right there is g of x. Well, we know what g of x is. G of x is x minus 3. So we're going to replace g of x with x minus 3. And so we found functions before. We would, you know, f of 3, just like we did before. F of 2, f of 10, f of negative 5, f of 1/2, things like that. But instead of finding f of a number, now we're finding f of an expression. We did this the other day when we started talking about functions and things like that, plugging things in. So we're going to take x minus 3, and wherever there's an x minus 3, or where there's an x in the function f, you're going to replace it with that expression. So we're going to replace x with x minus 3. So it's x minus 3 squared. And then you'll simplify that, which is x squared minus 6x plus 9. And so we've created this one machine or one function that does both things. And so we have f of g of x. So instead of plugging into g of x, taking it out, plugging into f of x, and taking it out, now we can just plug it into this expression, x squared minus 6x plus 9, and then when we take it out, it's already done both things for you. So let's look at the second part, which is g of f of x. So if we switch it around and plug it into the dryer, and then take it out of the dryer and plug it into the washer, are we going to get the same output basically? And if you look at this one, we're going to plug g of and then f of x. Now f of x is x squared. So we will replace the x with x squared, but now this is in the function g. So wherever there's an x in the function g, we're going to replace it with the x squared. So x minus 3 now becomes x squared minus 3. And we can't do anything with that, so this is g of f of x. So obviously those two things are not the same, so no, g of f of x and f of g of x do not equal the same thing. They create basically two different machines depending on how you're wanting them to be put together. Okay, so that's a composition of functions. Here's another example. Instead of finding f of g of x and g of f of x, I've actually plugged in a number now. So you can find f of g of 3 and g of f of 3. Giving you two different functions to look at here. On part A, we're doing f of g of 3. So we could find f of g of x and then plug 3 in. But let's do it in kind of two parts. Instead of creating the composition, let's actually do it in two parts. We're going to find g of 3 first. So it's f of g of 3. So we plug 3 in for the g function. And if we do that, that would be the square root of 4 minus 3 squared. And so f of the square root of 4 minus 9 would be negative 5. Well, we run into a little problem here. Square root of negative 5 is an imaginary number. And if you go back to when we talked about domain, we're talking about real numbers here. So we're done. We can't go any farther. This is not going to work because when we plug that value into f, it doesn't exist in terms of real numbers. So f of g of x does not exist. And that's because 3 is not part of the domain. So let's look at the second one. What if we switch it around? Does that mean it's not going to exist if we do g of f of 3? Well, we already found out that they're not the same thing, so it doesn't necessarily mean it's not going to work. We're now going to plug in f of 3 first. Well, if you look at the function f, there are no restrictions in the domain for f. It's a quadratic. You can have all real numbers. So if you're looking at these ahead of time and thinking about what type of functions they are, they'll give you an idea of whether you're going to be able to do it or not. So this will be g of f of 3. So now we're going to plug 3 in, so it'd be 3 squared minus 8. And that's 9 minus 1, or sorry, 9 minus 8, which is 1. And so now you're finding g of 1, which is the square root of 4 minus 1 squared, or 4 minus 1, and that's the square root of 3. So this one does exist. So g of f of 3 does exist. It's the square root of 3. So obviously in the g function, 1 is part of the domain, whereas 3 is not part of the domain. So kind of a little bit of a bonus question here is what is the domain and range of this function? All right, and you can't, the first thing people want to do is they'll want to find what f of g of x is. And I'll tell you right now, f of g of x is equal to negative x squared minus 4. And so if you look at the domain, we're going to say, okay, the domain's all real. But we know the domain's not all real because 3 didn't work. So what's going on here? When we find the composition, it seems like the domain's all real, but we found out it's not all real. Well, if you look at this, the first thing that you're doing is g of x. Well, g of x doesn't have a domain that's all real. So you cannot plug in, sorry about that, you cannot plug in whatever you want. Oh, I just erased everything I did. Great. You cannot plug in whatever you want into that function. Sorry about that. I don't know what happened. So as I was saying, f of g of x was equal to negative x squared minus 4. And we were saying, I don't have it up there anymore, I don't know what happened, but the 3, it didn't work. So what's the problem? Well, you want to look at your domain of this one and find out what that domain is. And what you'll find out, and I'll kind of let you do this and we can talk about it in class, but the domain of this one is all values between negative 2 and 2. So your domain is not all real numbers. Your domain for this is negative 2 and 2. And if you plug this domain, because you're going to have to plug that into your function f, do all of those values work? Well, because f of x has a domain of all reals, then yes, any of those values between -2 and 2 will work. Okay, so I'll let you kind of finish that one and we can talk about it a little bit more in class, but I don't know what happened in terms of me closing out or whatever, but it did erase that, but I'll fix that on the notes for you guys. So the last thing I want to do and kind of finish us up pretty quickly here is, the last thing I want to look at is the decomposing. We want to take a function h of x and we want to write it as a composition of functions. So there's two questions here, so we'll split these up. So here's the first one. I'm giving you basically the answer and I want you to write the two functions. So what would work to say f of g of x will give you the function h of x? How are you going to do that? When you look at this, think about your inside and your outside. This right here, your g of x function, represents the inside. Okay? The f represents the outside. So what's the inside of this function? What's happening on the inside? Well, 3x minus 5 is the inside. So that represents your g of x. 3x minus 5. What's the outside? Well, the outside is what's happening to that 3x minus 5, and it's being cubed. Okay, so that's the outside. So your f of x represents what is happening, which is x cubed. So if you think about this and you figure this out, you're taking the g of x, plugging it into the f of x, and that's where you get the 3x minus 5 cubed. Okay, so that's how decomposing works. You're working backwards. So look at b. Alright, if you want to pause it just real quick and try this. You know, what is on the inside? What is happening here? Well, the inside is the x minus 2. So your g of x is x minus 2. What's on the outside? Well, the outside you have, you know, what's happening to the x minus 2? Well, it's getting squared and you're doing 1 over that. So your f of x is 1 over x squared. And so when you plug that in, then you'll get 1 over x minus 2 squared. So that's decomposing a function. Okay. So in terms of your homework, once again, some odds here that you guys can look at, and then some open-ended questions at the end with 79A and 83. And that is it in terms of combinations of functions. Thank you.